Hello. Today we're going to talk about Coulomb's law. Okay, so we're going to talk about charge. So static charge, right? Let's say it's a positive and a negative, right? So this is static charge. So you will have attractive force going this way between these two charge, right? And we're going to call that the electric force, right? So this is so-called electric force. And if you have 2 plus, well, I should draw it this way, right? So it will be going this way, and for this charge, it will be going this way, right? Okay, so in this case, same thing here. This will be going this way, and this will be going this way. Okay, and negative, negative too, right? So negative, negative will be going this way and this way. Okay, so what does Coulomb's law does, right? So before we do that, we're going to define the units, right, for the charge. Okay, the unit we use Coulomb, or we use C, right? So 1 Coulomb of charge is quite a bit, right? Because 1 electron has 1.6 times 10 to the negative 19 Coulomb, right? And this is so-called elementary charge. So this definition is very, very important because in the world, right, in the universe, there's only n, which is a multiple, right, which is an integer. Okay, not a real number, but integer. N times this elementary charge. Okay, so it does not exist something in between, like a fractions of this elementary charge. So this is a very basic of charge. So you can have 1 of this, 2 of this, 3 of this, but not 2.5 or 2.3 of this. Only the multiples. Okay, so I'm going to clear that. And we're going to talk about Coulomb's law now, right? So Coulomb's law says that this Fe is equal to K times Q1, Q2 divided by R squared. Okay, so let's say we have 2 positive charge. And we kind of like fix it there, okay? Whatever way that you can do, okay? And we say that this distance is R. So then this Fe is this one here. And it's also this one here. But notice, one go to left, one go to right, right? So this is actually only describing the magnitude here, right? And if you want to put the positive, positive in there, you can put positive, positive. You can see this is going to be positive. So that tells you it's a force that kind of repel each other, right? So this is kind of repulsive. Okay, all right. So Q1, so we're going to say this is Q1 here, right? So I just have 1 plus, but it doesn't mean it's 1 plus, okay? It just means it could be multiple, right? So Q2, right? And they both are positive. So let's say Q1, well, and then K, this is called Coulomb's constant. Coulomb's coefficient, okay? And this one is equal to 9 times 10 to the 9. And what's the unit? Since this is Newton, this is C, and this is m squared, right? So you can see I move this there and I divide. So then this one here, the unit will be Newton times meter squared divided by c squared, okay? So that's called Coulomb's coefficient. And then, but there's also another way of defining this, which is epsilon 0 is equal to 1 over 4 pi k. And that's called the permittivity. Of free space. So this one here is a very fundamental constant that will be used in relativity, in quantum mechanics, right? So also will be used in the capacitance. All right. So then this epsilon 0 in value is equal to 9 times 10 to the negative 12. Okay. And the unit is c squared, so reverse of that. And then n m squared. That looks a little weird. Negative 12. I guess that's fine because this is 4 times 3, so that's 12. Yeah. And then times k. So that looks about right. Okay. Okay, so I'm going to give an example. Right. So the example is, let's say if I have 1 Coulomb here, and then I have a minus 2 Coulomb here, and then this distance here is 1 meter. If I changing this to 2 meter, but this is still 1 Coulomb and minus 2 Coulomb. So what is, so that's called this one F1E, right? Stand for electric. This is called for F2E. What is the ratio between these two forces? So the easiest way to do this is, you know, this distance is increased by 2, so then this F2E, right, will be smaller. And since we know Coulomb's law is K Q1 Q2 divided by R squared, so as R increased by 2, the force should be divided by 2 squared, right? So it will be a quarter of the F1E in the magnitude, okay? So that's, and then this, so you can calculate the absolute value too. Let's say F1E, that will be equal to K, so 9 times 10 to the 9, right? 10 to the 9, right? And then Q will be 1 times, you can put, I would just put 2, okay? And then you explain that's a attractive force of, or you know, repulsive force, right? So you calculate this, and that will give you, you can see it's a fairly big number, right? So this is in terms of Newton, right? So that's like, this is equal to 9 times 10 to the 9 Newton, right? So that's huge, right? That's a huge amount of force. So you know, Coulomb is a very big charge unit, okay? All right, that's all we have today for the Coulomb's law. Thank you, and I'll see you.